Very good morning to one and all my dear friends. How are you all? Good. Welcome once again to this new session of Physics Today. And today we are going to discuss about one of the very important article of current electricity, which is called the drift velocity. So drift velocity, my dear friend, is represented by the sign which is called V for velocity and small d for drift. Now all of you can easily understand that as the name suggests, it is the velocity of drift of the charged particle. Now we all know that inside a conductor there are a large number of charged particles which are in continuous random motion and they are constantly colliding with each other, and due to which all these charged particles are having thermal velocities which may be of the rate 10 raised to the power 5 to 10 raised to the power you can say 6 meters per second. This is the range of velocity which is due to the thermal collision between the charged particles. But on an average, the total thermal velocity inside the conductor is considered to be zero. It is considered to be zero. So it means if we consider that there are n number of electrons which are present inside the conductor, and each electron is having let us say the thermal velocity as U1, U2, U3, U4 and so on, then according to the concept of the average thermal velocity, it is zero. It means when we talk about U, that will be equal to U1 plus U2 plus U3 plus U4 plus Un over N, and this is equal to 0. So average thermal velocity will be 0. This is one of the very important article now. Now when we connect an external source to the conductor, what will happen? Due to this electric field, the charges or the you can say electrons will be drifted or will be accelerated from one terminal to another terminal with a constant velocity. It may be, but when they drift, they collide with ions. When they drift, they collide with ions and they gain some extra energy due to this collision. They gain some extra energy due to this collision, and with this extra energy, when they go and try to reach the other collision, there is a time gap between that these two collisions, and that is called relaxation time. That is called relaxation time. So what is relaxation time? A relaxation time is that short duration of time between two collisions of the charged particles with the ions or each other. So whatever is that very small, you can say, time of gap between two collisions, that is called relaxation time. Is it clear? Now the velocity with which these electrons are drifting, with which they are moving from one terminal of the conductor to another terminal of the conductor, that average velocity is called the drift velocity. So drift velocity basically is that average velocity with which an electron is moving from one terminal of the conductor to another terminal under the action of applied electric field. And you will appreciate that the direction of this drift will be against the direction of applied electric field. So these electrons will drift in a direction which is opposite to the direction of the applied electric field. Is it clear, my dear friends? Okay. So now, dear friends, if we derive the equation of the drift velocity, for that what we will consider? We will consider a conductor which is applied with an external electric field, either by a battery. Then you can very well see that if suppose this is a conductor which is connected to an external source, and these are the charged particles, which are obviously, for the time being, we are considering only the electrons. This is positive and this is negative. Now you can understand that the moment we conduct this electric field, these electrons will experience a force due to which they will be drifted towards the another, you can say, a terminal of the conductor. And what is that force? That force is given by minus E into E. F is equal to minus E into E, where E is the charge on the electron and capital E, as you know, it is the strength of the electric field. And this minus sign clearly indicates that the force which is exerted on the electron will be in the opposite direction of the applied electric field. It will be opposite direction, and this force will make the electrons move, and the movement of electron will obviously result in the conduction of current. So current will start flowing through the conductor. Now, when these electrons starts moving, it means they start getting accelerated towards the another end, and this acceleration we know from another equation of motion, which is second law of motion. F is equal to m into a. So our A will be equal to F by m. So acceleration produced inside the conductor on the electrons will be given by this, and your F is this. So A is equal to minus E into E by m. This is the acceleration which is produced in the electrons when the electric field is applied. And as I have told you in the previous topic also regarding relaxation time. So when these electrons will be accelerated, they will collide with each other and the other ions, and between the two successive collisions, whatever is the short duration of time, that will be termed as relaxation time. It means each electron is moving with a velocity which will be a sum of the thermal velocity and the velocity acquired by the electron due to the force which is applied by the electric field, due to the force which is applied by the electric field. That means Vd will be equal to U plus A into tau, where U is the thermal velocity, A is the acceleration, and tau is the relaxation time. And tau is the relaxation time. And everybody knows that in a conductor, the average thermal velocity is considered to be 0. So Vd will be equal to 0 plus the value of A, which is minus E into E over M and into tau. So finally what we get, Vd is equal to minus E tau over M. This is the value of the drift velocity which is obtained inside, which is attained by the electrons when the electric field is applied and they start moving from one terminal to another terminal with this particular velocity. Is it clear? So after this, we will continue with another topic which is going to give you the relation between the drift velocity and the current. The relation between the drift velocity and the current. So my dear friends, now we are going to start with the article which is the relation, that is called the relation between the drift velocity, which is Vd, and the electric current I. So this is our topic, the relation between Vd and I. Now suppose if we consider a conductor which contains the electrons. Obviously there are charges also, but we are talking about electrons. So if suppose there are electrons inside the conductor, and when you apply an external source of energy which is having the potential V, and if suppose L is the length of the conductor, so obviously due to this V, there will be a development of the electric field which will exert a force on the electrons. Now we all know that the strength of this electric field will be given by V over L. This is the strength of the electric field which is experienced by the conductor. The strength of the electric field is there. Now, if there are, if suppose N is the number of electrons per unit volume, if N is the number of electrons, this is per unit volume, then you know the total number of electrons, will be equal to how much? Number of electrons कितने होंगे? That is N multiplied by the volume. Because what is N? N is the number of electrons per unit volume. So total electrons will be N into volume. So total electrons will be N into volume. Volume of the conductor, and that is obviously the curved surface area into the length. This is your number of electrons. Now if suppose every electron, as you know, it is having a charge E. If E is the charge on the electron, then total charge Q will be equal to N into A into L. The total charge will be equal to N into E into A into L, because टोटल नंबर ऑफ इलेक्ट्रॉन कितने हैं, इतने हैं, और हर इलेक्ट्रॉन पे चार्ज कितना है, E, तो टोटल चार्ज कितना हो जाएगा, मल्टीप्लाई बाय E, as simple as that. So this is the total charge which is there on the particular, you can say, conductor. Now we all know, according to the definition of current. Now what is current? What is current? Shabash. Current is the charge per unit time. Current is the charge per unit time. So that means I will be equal to N E A L over T, charge per unit time. This is what is the current flowing through the conductor when you apply a potential and any doubt till here. So if I find the value of this, you can very well understand that what is T. What is T? The time taken. Shabash. Time कितना होगा बेटा? Time to and time taken by the electron to reach from this end. From this end to this end. What will be the time taken? Time is equal to distance by speed. Time is equal to distance by speed. And what is the length? That is the distance. And what is the speed? It is drift velocity. It is a drift velocity. So distance over drift velocity, that is your time. Any doubt? So T is equal to L by Vd. This value you can put here. And when you put this value here, what do you get? Let me write here. What do we get? I is equal to N E A L over L over Vd, and I will take this Vd up. कोई डाउट? T की जगह हमने क्या लिखा? L by Vd. तो L से L कैंसिल हो गया, तो what do I get? तो I is equal to N E A into Vd. And this is the relation between the current and the drift velocity. I is equal to N E A into Vd. And you know each and every term associated with this. I current हो गया. N is the number of electrons which are present inside the conductor. E is the charge on the conductor. A is the area of cross section of the conductor. And Vd is the drift velocity of the conductor. Of the electrons. Drift velocity of the electrons. So, any doubt? I hope this article of drift velocity as well as the relation between the drift velocity and the current is clear to you. And now we will be solving a couple of numericals based on that, so that you can develop some confidence regarding the numericals also. So my dear friends, as you can see on the board, I have written a small numerical for you. I will just read out the statement, and whatever I have obtained from the statement that I have written here, in the same way you also have to write. Let us see. A wire of length 6 meter, and area of cross section 1 mm square, carries a current of 2 amperes. If a unit cubic meter of the material of wire, unit cubic meter you can understand, if the unit cubic meter यानी जिसकी जो volume density है that is 1 meter cube, if the cubic meter of the material of wire contains 10 raised to the power 20 electrons. That means this is n given to you. Find the average time taken by the electron to cross the entire length of wire. If this is the length of the wire, how much time will it take to start from here and reach till here? This is what we have to find out. And you all know that the formula for finding the time is just now we have done in the last article. Time will be equal to distance, which is obviously the length, over the drift velocity. Over the drift velocity. It means my first priority now will be to find the drift velocity. And what is the formula of Vd? Now I is also given. So Vd and I can associate. We know that what is I? I is equal to NEA into Vd. So what will be Vd? Vd will be equal to I divided by N, E and A. You are having I? Yes. You are having N? Yes. You are having E? Everybody knows the charge of the electron. I don't have to tell. And you are having A also. So when we put all these values together, what do we get? When we solve this, 2 divided by 10 raised to the power 29 into 10 raised to the power minus 6 and the charge on the electron, which is 1.6 into 10 raised to the power minus 19. 1.6 into 10 raised to the power minus 19. When I solve this, I get Vd is equal to 1.25 into 10 raised to the power minus 4. 1.25 into 10 raised to the power minus 4. Okay, 19 and 6. 19 and 6 is 25. So 29 minus 25 is 4. And when this 4 goes up, it becomes minus 4. So this is the velocity of movement of the electrons from the conductor. Now this value you can put here, and finally what you will get? E is equal to 6 divided by 1.25 into 10 raised to the power minus 4. This will come up. You will get 10 raised to the power 4 into, and when you divide 6 by 1.25, what you will get? You will get 4.8. You will get 4.8. So T is equal to 4.8 into 10 raised to the power 4 seconds. And if you want to convert it into hours, you can also convert. See how easy it is to solve a numerical if you have a concept very clear to you and the formula known to you. We will do one more of the same type and then we will continue further. So now I will read one more question for you so that you can develop a little confidence in that and then we can proceed further. The conductor with an area of cross section, a conductor with an area of cross section 10 raised to the power minus 4 meter square, 10 raised to the power minus 4 meter square carries a current of 1.2 amperes. So I is equal to 1.2 amperes. If the number of free electrons, that means N is given to you 5 into 10 raised to the power 28. 5 into 10 raised to the power 28 electrons are there. Then calculate the drift velocity of the electron. You have to find Vd. As simple as that. Because current is known and we know the relation between them. So I is equal to NEA into Vd. And what we will get? Vd is equal to I over NE and A. You have N, you have I, you have A, and also you know what is the charge on the electron. So you can easily solve this. So keep doing your good work, my dear friends. Try to get maximum practice on the numericals because it's very important to practice the numericals because conceptual things I am always there to help you out. I am trying to make the concepts of the things very, very clear to you. But numericals, my dear friends, you have to practice on the spot. So keep doing as much as possible for the numericals. And till our next class, do take care of yourself. Keep doing the good work and make every one of us proud. Thank you and God bless.